Today we're going to do 7.5 notes. This is called Simplifying Radicals. So this actually kind of takes a break of what we've been doing, and this lesson will help us with the next lesson that we will be doing next time we have class. So let's get started. All right. So it says here, what is a radical expression? It is the expression that contains a radical. An example would be like the square root of 20. And if you look at the paper quickly here, you will see that on this side, none of these are perfect squares. So normally when you would have to solve this, you would put it into your calculator, put the square root of 24 in, and then you would get some kind of a decimal. But how do we do this without getting decimals? So I'm going to show you that now. So first, I would pick two factors of 24. So if you want, you could use your factor sheet if you can't think of what times what makes 24. Okay, so we did that earlier. We did 24 earlier. So let's see. We could use any of these to break down. Now, I would never advise to do the 1, but you could do like 2 and 12, 3 and 8, 4 or 6. So I would pick 4 and 6. So I take the 24 and I break it down. So what times what makes 24? Well, we said we could use 4 and 6. And then I keep breaking it down. So 4 can break down to 2 and 2. And 6 can break down to 2 and 3. So I look at the end of my branches, 2, 2, 2, 3. I write those out. And I find pairs. So I have a pair of 2's. And then these are my leftovers. Okay? So here's your radical. Your pairs. So I only have one pair. I take 1, 2 from the pair. I only have one pair of 2's. So 1, 2 on the outside. The leftovers, I multiply back together and I put that inside of the radical. Okay? So that is the basic. How do you simplify a radical? That's how. So let's try 80. Okay? So for 80, you could pick like 8 and 10. I try to pick numbers that are kind of like close to each other. Like if I picked 2 and 40, 2 and 40 are quite far apart. So I'm going to pick 8 and 10. It doesn't honestly matter. Just don't pick the 1. So 8 can go 2 and 4. And 4 can break down to 2 and 2. 10 can break down to 2 and 5. Okay, now we have 1, 2, 3, 4 2's and a 5 at the end of my branches. So all of these were at the end of the branches. So now I'm going to pick my pairs, or find my pairs. And now I have 2 pairs of 2's. So on the outside, I take 1, 2 from this, and 1, 2 from this, and 2 times 2 makes 4. The leftover 5 just goes back inside the radical. So my answer would be 4 radical 5. Okay, 360. For this one, I'm going to use 10 and 36. So for 10, I obviously would have 2 and 5. For 36, I'm going to go with 6 and 6, which breaks down to 2 and 3, and 2 and 3 again. So I have 1, 2, 3 2's, 2 3's, and a 5. So I'm going to pick this pair of 2's, this pair of 3's, and then 2 and 5 are left over. So I take 1 2 and 1 3, and that makes 6. Multiply those together. 2 times 3 gives me 6. The leftover 2 and 5 I multiply and put back inside the radical. Okay, letter D. I take the 125, break it down to 5 and 25. 25 can break down to 5 and 5. This gives us 3 5s, where I have one pair of 5s. So the pair, take 1 5, put it on the outside. The leftover 5 goes on the inside. Okay, so that is how you simplify a radical when it's just a number. But if you look at example 2, we have a number and we have a variable with different exponent values. Okay. Also note that the variables are changing here. You're not always going to see x, so I wanted you to see that in the notes that it could be really any variable. Okay, so now for 72, first thing we're going to worry about is the number. So for 72, we're going to break it down. Let's go with 6 and 12. Keep breaking it down. Okay, we could go 3 and 4, 2 and 6, doesn't really matter. So this gives me 3 2s, 2 3s. Then I also have those 4 x's, x to the 4th. So I'm going to write out 4 x's. Now, find all of your pairs of everything. Alright, so we have a 2, 3, another x, and an x. Okay, so 2 times 3 gives you the 6. Since we have an x and an x, that would be x squared. Left over is just a 2. So this is how you write your answer in simplified radical form with a number and a variable. Okay, part B, that 12, break it down. So I have a 2, 2, and 3, and 6 C's. So let's circle all my pairs. So I have a 2, I have 3 pairs of C's, so that's C to the 3rd, and then the leftover 3 goes inside the radical. For 90, I'm going to use 9 and 10. I have a 2, 3, 3, 5, and 5 B's. Find your pairs. Okay, so I've got 3 B's squared. 2 B's, so 3 B's squared. Left over, I have 2 and 5, which makes 10, and a leftover B that goes back inside the radical. Okay. For letter D, take the 240. I'm going to break it up to 10 and 24. Okay, so that gives me 4 2's, a 3, and a 5. I also have 7 W's. Okay, so we've got many pairs here. I've got those 2's and these W's. So that would be 2 times 2 would be 4. I have 3 W's, so W to the 3rd. 3 times 5 would be 15. And then that W. For this part, it says you're going to multiply 2 radical expressions and simplify the 2 radical expressions to make 1 radical expression. So the first thing you want to do is look on the outside, like the front of the radical. We have a 7 and a 3. We're going to multiply those together right away. Then on the inside, you're going to multiply that 5 and that 20. So on the outsides, they go together. On the insides, they go together. So 5 times 20 gives you 100. Then we have x to the first here and x to the fifth. You should hopefully remember that when you are taking x, or when you are multiplying the same base, that means that you're really adding those exponents together. Okay, we did that way back before the first semester final exams. So 1 and 5 would make x to the sixth here. All right, so first thing, you have to know that this means 21 times the square root of 100 x to the sixth. So that 21 is going to be a staple. It's not going to really go anywhere. We're going to keep it right there. Okay, times, well, the square root of 100, perfect square, is 10. And if I wrote out 6 x's, 1, 2, 3, we have 3 pairs. So there's no leftover, so that would go on the outside of the radical. Well, as you can see, there's nothing left over, so I don't need a radical. And I would go ahead and multiply these two numbers to get 210, and then bring x to the third down. Let's try it again. So for part B, we look at those outside numbers, 2 and 3. That gives us 6. Inside, 7 times 14 would give me 98. Then we have a to the first and a squared, which would be a to the third. All right, so now we have 6 times something. Well, 98 is not a perfect square, so we're going to have to break it down. So 98, I know that that is divisible by 2 because it ends with an 8, even number. So I'm going to say, okay, well, 2 can go into 98 49 times. So if you don't know that off the top of your head, you would take 98 divided by 2, and then you would know you'd have 2 times whatever the calculator would say, which is 49. And that can break down to 7 and 7. So I have 2, 7, 7, 3 A's. Okay, so I have a pair of 7s and a pair of A's. So 7A is going to go on the outside of the radical, and the 2A remaining would go on the inside. So 6 times 7 is 42A. And then the square root of 2A just comes on down. And that is my final solution. Okay, now when you have a fraction. So this one, these two I actually made pretty small answers here because they're very fast to do. These are perfect squares. So the square root of 64 is 8, and the square root of 49 is 7. I am not going to change it to be a mixed number. I'm just going to leave it improper. Okay, but it does say answers must be simplified form. So square root of 9 is 3, square root of 36 is 6, but 3 sixths can reduce to 1/2. Now, if you notice, for the rest of the notes, the denominator, the bottom part of the fraction, are all perfect squares is what you want, actually. Okay, so that's a good sign. So I'm going to go ahead and figure out, okay, well, the square root of 64 is 8. That's done. I have to go ahead and work out 44. So I'm going to use 4 and 11. And then that 2 breaks down, or sorry, the 4 breaks down to 2, 2. Okay, so I've got a pair of 2's that goes on the outside, and the leftover 11 that goes on the inside. Now, you've wrote it in the simplified radical form, but the 2 8ths that is on the outside of the radical, that actually can be simplified because it's not in a radical. So the 2 and the 8 can be divided by 2. Okay, so 2 goes into itself 1 time, 2 goes into 8 4 times. So it looks like this. But you never see anyone write a 1 in front of the radical like that. So your answer would just be radical 11 over 4. Okay, so this right here is called a radical. You square root the 11, but the actual symbol is called a radical. Okay. Moving on, letter D. We have that square root of 100 at the bottom, which is 10. 18 can break down Okay, that 3, it looks like, is my pair, and my leftover 2 goes inside. Now, that 3 and that 10, they cannot reduce. I can't reduce this part because that's in a radical and that's not. So it's like not like terms really. So we're just going to leave it like this as my solution. Okay. Last but not least here, we got E and F with variables. Okay, so first we have 3 parts to work with. The 25, that's going to make 5. Okay, we're going to work with the 32 next, and we're going to go with 4 and 8. So we have 5 2s. Okay, now, before I circle anything, let's take care of the a's. So when you have the a's in a fraction form, you subtract them. So 7 minus 3 gives me a to the 4th. So I'm looking at 4 a's, and now I find my pairs. Okay, so I've got 2 times 2, 4, and then a times a is a squared, with a leftover 2. All right, so 4/5 cannot reduce, so this is my final solution. I'm going to start one more time, then we are done for the notes today. Square root of 64 is 8. 12 can break down to, let's go with 3 and 4. The x's, so 9 minus 2 is x to the 7th. That is a lot of x's. Okay, so we got a pair of 2's, x, x, x. Okay, so 2x to the 3rd with a leftover 3x. 2 8s can reduce to be 1/4. But as I said, you wouldn't write that 1 in front of the x to the 3rd like it just looks silly. So I would say x to the 3rd square root 3x over 4.